Hi there everyone, and welcome back to week 12 of the Maths Tutor exam countdown. So as you can see, today is all about integration, and I've linked to some very good videos in the chat there on some past exam questions for integration. So the first one is from 2017 paper 1. And it's using integration to find the area between two curves. And the second one is from 2015 paper 1, and it's using integration in the context of the length of a day in Galway, that question there. So let's jump straight in. You might have remembered me mentioning before that integration comes under the umbrella of calculus. So the last time we differentiated, we had started with a function which we called it f of x, and in order to find f dash x we needed to differentiate. Okay, so we knew how to do that. We multiplied down by the power and reduced the power by 1. However, to go the opposite direction, so starting with your derivative to get back to your original function, we do the opposite and we integrate. So integration is basically just the opposite of differentiation. It's undoing that differentiation. And just like you had for differentiation, your log tables are going to be very, very handy for integration as well. This time it's page 26, and you will see all of the rules there, most of which we use on the Leaving Cert course. And just to zone in on this one here, I suppose, that's our general rule for integrating. So let's write that down in words over here. When we're integrating, we increase the power by 1. So we increase the power by 1 and we divide by the new power. And you can see that there from your log tables anyway. So as you can see, it was x to the power of n, but when we integrate, it becomes x to the power of n plus 1 divided by the new power of n plus 1. So how you're going to see how integration looks is you're going to see this kind of elongated s. You're going to be integrating a function, and you're going to have a dx or something similar at the end. And sometimes you're going to have a number here and a number here, and these are just what we call the limits of integration. Okay, this is here is my integration sign. This is the function that I'm integrating, and this just tells me what variable I'm integrating with respect to. Okay, so we're going to jump straight in, and I'm just going to go through a couple of notes on integration first of all under these 4 headings. So starting with indefinite integrals. Basically, in short, what an indefinite integral is it's one that we don't definitely know the answer to. So we're not 100% sure of the exact answer at the end. So just to get you started on that, if I gave you a function, for example, x squared. So I gave you a quadratic function, x squared, and I asked you to tell me what f dash x was. So if I asked you to differentiate it, you would end up multiplying down by the power, reducing the power by 1, so you would get 2x. And similarly, if I gave you the function x squared plus 3, you would get exactly the same derivative, 2x, because remember, when you differentiate the 3, that constant goes to 0 when we differentiate. So if we work backwards, and if I asked you to integrate 2x with respect to x, well, you would increase the power by 1, so that would become x to the power of 2, and you would divide by the new power, so that would give you an x squared, because as you see, the 2 on top and the bottom cancel each other out. So what we do, because we're not sure if there was a constant here in the first place, we add in this, what we call the constant of integration, this plus c. And that is basically just standing for our constant of integration. Maybe there was no constant there in the first place. In that case, your c would be 0. But maybe, like this example over here, maybe there was a constant, and we will be given extra information in the question, I suppose, to work that out then. So an indefinite integral means we're not definite of the answer. We always have to include our plus c, our constant of integration. On the other hand, a definite integral then, so a definite integral would look something like this if I use the previous example, 2x dx, but this time we would have what we call limits here. So I'm just going to put in any numbers there, for example 5 and 3. So what we do in this case, our first step, we integrate as normal, and we're going to come across a couple of these examples in a minute from the exam papers anyway, and then what we do is we take our function, our answer, so when we integrate, whatever answer we get, we sub in 5 for x, we sub in 3 for x, and we subtract 1 from the other. So we always start with the upper limit, the higher, the bigger number. We sub that in first into our answer, of course, after integrating. We sub in our second limit, so that's the lower limit, and we subtract 1 from the other. And in this case, there's no need for a c, because when you subtract here, the c's are going to cancel out. So you're going to end up with a plus c here, a plus c here, but of course when you subtract them, those c's are just going to cancel out. So that's why we call this one a definite integral, because we're definite of the answer. There's no ambiguity here whether there's a constant at the end or not. Okay. Very quickly moving on to the area under a curve. So like I said, we are going to be looking at these examples in the exam papers anyway. Okay, so area under a curve. So let's just give an example here. We have our x and our y axis, and I want you to imagine that you have a U-shaped quadratic curve, and just to show it a little bit clearer, a N-shaped quadratic curve as well. And just imagine that we're looking for the shaded area in between those two curves there. Very simple. What we do is we, first of all, I suppose, find the points of intersection. So we'll just say where the two curves meet. So I'm going to call that point there P, and I'm going to call the x value of that point there Q, and they become our limits of integration. So the higher number there is obviously Q, it's further along the x-axis, and the lower number is P. And I forgot to say here, we'll call that U-shaped function, we'll give it a name f of x, and we will call our N-shaped function, so the pink one here, we'll call that g of x. So what we always do, we integrate between our two limits, so between our 2 points of intersection, and we always take the top curve minus the bottom. So in this case, it's clear to see the pink one is on top. So we're going to integrate g of x, and we're subtracting the bottom curve f of x, and obviously dx at the end, because that's my variable. So it's always the one on top minus whatever the one visually on the bottom is. So it should be fairly easy to see that from the diagram. Clearly in this example that I've given you, the one on top is this pink one here. It's the one visually on top, whereas the purple, the f of x, is the one visually on the bottom. Okay, and the last thing then is a formula that we need to be able to remember for the average value. So if, for example, you were looking for the average value of a function between two certain points, or between two certain values, our formula is 1 over b minus a, so where b and a are your limits of integration, or the two values that you're looking for the average value between. So b is obviously your upper limit, and a being your smaller number. So it's 1 over b minus a, and it's the integral between b and a, so those are our limits of whatever your function is with respect to whatever your variable is. So this is an important one, I suppose. It comes up quite a bit, and it's unfortunately not a formula that's given in the log tables. Okay. So if we go back to what you are given in your log tables, we had that over here. Those are what you are given in your log tables. So yes, you're given your cos, your sine, and your tan, just the regular ones. You're given your exponential functions, your 1 over, and your constant to the power of x. You're told how to integrate those, and that's really all that's in the log tables for integration. There's no such thing as a product rule, a quotient rule, or a chain rule. So we have to try kind of work our way around those. So just to very quickly recap, I have really quickly just gone through the 4 kind of headings for integration, I suppose. So your indefinite, your definite, your area under a curve, and your average value. So what we'll do is we'll have a look at a couple of exam questions. We'll hopefully have time for 2 or 3, and we'll put all of that information into action as such. So we're going to start with this one. This is 2019 paper 1, and it is part of the question 4. So we're going to do the part A and the part B part 1. And the part B part 2 is just, I leave that to yourselves. So it's just a little bit of algebra with cubic equations. So nice and straightforward. We're asked to find, and there's our symbol for integration, a little bit better than I can draw it. And this is just a very, very straightforward integration where we're just increasing the power by 1 and we're dividing by the new power. So our answer is going to be 4. It's going to be x to the power of, so increase that power by 1, it becomes 4, and we're dividing by the new power. Minus 6, remember that's an x on its own, so there's an invisible power of 1 there, so it becomes 6x to the power of 2, when we increase it by 1, divided by the new power. And when we have a constant on its own, like this 10 here, we're just adding in an extra x. Why? Well, really it's 10x to the power of 0, so if you increase that increase that power by 1, you get x to the power of 1, and you're dividing by 1, so it's the same thing as 10x here. And you would be expected to simplify. So if you see here, the 4 divided by 4 is 1, and the 6 divided by 2 is 3, so that will give me x to the power of 4 minus 3x squared plus 10x. And don't forget, this is an indefinite integral. We're not 100% sure. Maybe there was a constant at the end, so we will add in our plus c. If you don't put in that plus c, you will lose marks in the marking scheme. So try put it in, get in the habit of putting it in for every single question once it's an indefinite integral. Okay? So part B, part of the graph of a cubic function, so you can see it's an S on its side, is shown below. The graph cuts the x-axis at 3 points, A, which is 2, 0, point B, and the point C here. And what we're told is that f dash x, so the derivative is this, show that the function, the original function was this. So let's remind ourselves, remember we said at the very start that if you start with your function and you want to get to your f dash x, you obviously differentiate. But this time we're starting with our f dash x and we want to get back to our function. So we're going to do the opposite of differentiation. We're going to integrate. So we're going to integrate this derivative and that will bring us back to hopefully our original function. So we're integrating 6x squared minus 54x plus 109, and to be completely correct, we're integrating it with respect to x, so it's a dx at the end. So again, a nice straightforward integration where we increase the power by 1, so 6x cubed divided by the new power, minus 54x squared divided by the new power, and here's a constant, 109x, and don't forget it's an indefinite integral, so don't forget that plus c there. At this point, I will simplify a little bit. So just remind ourselves it was f of x we were looking for because we were starting with our f dash x and we were working our way backwards. So my function, f of x, well, look at what happens here. The 3 goes into the 6 twice. 2 divides into 54 27 times. So our function is going to be 2x cubed minus 27x squared plus 109x plus c. So getting very similar to what we have up here, we have the 2x cubed, we have the minus 27x squared, we have our 109x, but we don't have this constant at the end. We haven't figured out yet what that constant, what that plus c is. So if you go back to your diagram and just have a look in your diagram to see, is there anything there that might help us? So this is a diagram of our function. That's our function here. Is there anything else that we know about the function? Well, the answer is yes. We have a point here that we know definitely lies on the function. So we know that when x is 2, our f of x or our y should work out to be 0. So if I take my function and I replace every x with a 2, that's going to give me 2 times 2 cubed minus 27 times 2 squared plus 109 times 2 plus my constant. that should equal to 0. Why 0? Well, we've just said up here that this is definitely a point on the line, or on the function, on the curve, okay? So, simplifying what you have there, we're going to just throw all of this. That part can just go straight into your calculator, and it works out to be 126 plus our c equals 0. So therefore, that tells me that c must be equal to minus 126. So my constant must be 126, and therefore I can go back to this point here and replace my c with minus 126. So in short, my function is 2x cubed minus 27x squared plus 109x, and my c is minus 126, which is exactly the answer that they've given here. So those ones where they give you the answer and you need to work towards it, they can be quite nice questions sometimes because you have something to work towards. Okay, so I suppose the main point of interest there is both questions dealt with, if I just zoom out there a little bit, both of those questions dealt with indefinite integrals. So you notice there weren't any limits here on either of my integral signs. And they both dealt with, or especially the second one, dealt with us being required to know that integration is just anti-differentiation. It's just the opposite of differentiation. Okay, so moving along, 2018 paper 1 deals with another part of what I went through at the very start. This deals with the area between two curves. So part of the graphs of the function h of x is x, so that's your linear function, and k of x is x cubed, so that's your cubic, your s on its side, that function, are shown in the diagram. And we're asked to find the coordinates of the points of intersection of the two functions. So we're looking for the points of intersection. So if we think about it, if we just, I suppose, look on the graph at where the points of intersection are and see how many we expect. We have one point of intersection here, so they meet there, they also meet there, and they also meet up there for a third time. So we're expecting 3 answers here, and it's a good idea just to remind yourself of that at the start. We're expecting 3 answers. And basically what we're looking for is we're looking for where the graphs, where they intersect or where they meet. So we're looking for where that function k of x and h of x, where they meet, where they intersect, or where they're equal to each other. So at those 3 points that I've marked here, both of the graphs are equal at that point. They all have equal x coordinates. So my k of x from, my k of x from the question is x cubed. So I'm going to replace that with x cubed. My h of x is just x. And what we end up with, if I just move that x to the left-hand side, we end up with a cubic equation. Now, we're well able to solve quadratic equations. We use minus b formula, our guide number. Cubics we're not so sure of sometimes. So what we're going to do is we're going to have a look here at this equation and we're going to factor out. We're going to take out what's common. So you'll notice that both terms have an x that's in common. We'll take that outside the brackets, and inside the brackets we'll be left with x squared minus 1. I'm just going to throw that x in a bracket. So what we've got is we have two things multiplied, giving me 0. That means that one of them must be 0. So we're going to let each bracket, just like you would if you were using guide number, we're going to let each bracket equal to 0. So straight away there, that gives you one answer, x equals 0. And from this one here, we're going to get x squared is equal to 1. So that will tell me, if I get the square root of both sides, that x is either equal to plus or minus 1. Why plus or minus? Some of you might be asking. Well, plus or minus because when you square plus 1, so if I put plus 1 in there and squared it, I'll get 1. But also I'll get the same thing when I square minus 1. Minus 1 by minus 1 is also plus 1. Okay? So our 3 points of intersection, or at least our x values, one of them is x is 0. One of them is x is 0, which we expected here. One is x is plus 1, which must be this one over here. So if I was to drop a line down there, that point x coordinate is 1. And this one here must have x coordinate as minus 1. But have a look at the question. They specifically asked for the coordinates of the point of intersection. So we need our x and our y values. So what I'm going to do is I'm going to take my x equals 0, my x equals 1, and my x equals minus 1. And I'm either going to sub them into the f of x or, sorry, the k of x or the h of x that we had here. Now, h of x is nice and easy. It's just x, so I'm going to sub them in there. So it's going to be h of 0 is just going to be 0. So that coordinate is 0, 0. H of 1 is just going to be 1, because remember h of x is just x. So that point is going to be 1, 1. And h of minus 1 is going to be minus 1. So that third point is going to be minus 1, minus 1. And no harm to just go back to our diagrams and mark in those coordinates on it. So minus 1, minus 1. And obviously, make sure that your answers make sense in this case, which, judging by the diagram, they do. Okay, next question asks us to find the total area enclosed between the graphs. So straight away, I know it's going to be integration because we're looking for the area between two graphs. So let's go back to our diagram and just have a look at it for a second. We're basically looking for the area enclosed in there and the area enclosed in here. But you will see, if I call this area 1 and this area 2, you'll actually notice that both of them are exactly the same. One is just the other one flipped. So what I'm going to do is I'm going to find one of the areas and then I'm just going to double it to find my two areas. Makes no difference which you pick. I'm going to go with area 2. I'm going to find that because I know it will be positive. Whereas if I found this area here, because it's underneath the x-axis, that will work out to be a negative value. But all we do is we just change it to positive because area cannot be negative. So for part B, what I'm going to do is I'm going to find the area of 2. So I've called it A2 and I'm just going to double it. Okay, so let's think about what the area of 2 is. Well, our limits of integration, they're going to be this upper value here, which is 1, and this lower value here, which is 0. That's where the two graphs intersect. And have a look at which your top graph is and which your bottom graph is. So it's clearly visible here that our top graph is the line, which is h of x. And just to put it in a different color there, our bottom graph here, which is in pink or red, is our k of x. So remind ourselves what we said. We said it's the integral between the two limits of the top minus the bottom. So that's going to be the integral. Our limits were 1 and 0. And our graph on top, so the 1 on top was the x, the line, minus the 1 on the bottom is the x cubed. So this is coming from the line, which was on top, and this is coming from the curve, which was on the bottom. And don't forget it's dx because that's going to be your variable. So straight into our integration. We are getting, so when we integrate our x here, we're increasing the power by 1 and we're dividing by the new power. So it's going to be x squared over 2 minus x to the power of 4 over 4. So that's coming from integrating the x cubed. Normally we would put a plus c in there, but because I have limits of integration here, those c's are just going to end up cancelling out. So I'm not going to bother. What I often do is I just put a little reminder here that I'm not finished. I now need to sub in my limits of integration, 1 and 0, and remind ourselves what we said at the start. What we do is we find what f of 1 is, we find what f of 0 is, and we subtract 1 from the other. So when I say f of 1, I mean that we're taking our answer from here, so we integrate it as normal, and we're subbing 1 in everywhere we see an x. So it becomes 1 squared over 2 minus 1 to the power of 4 over 4. That's just a half, take a quarter, and that should work out to be 1/4. F is 0, it's a lot easier. You're just going to get 0 everywhere, and f of 0 works out to be 0. So when I combine the two, and I look at f of 1 minus f of 0, that should give me 1/4 minus 0, which is 1/4. But don't forget, just to remind yourself, that we said up here that we needed to double the area. So if I go back to my diagram, this area in here, so this area in here, A2, we've just worked out that that's going to be 1/4. This area here, area 1, must also be 1/4. So that's why we're doubling it. 1/4, 1/4 times 2, you should be getting 1/2, and its area, so it's going to be units squared in this case. Okay, so just to very quickly recap on what we've done then. So we've gone through, from 2019, we've gone through an indefinite integral where we don't forget to include our plus c at the end. And we've also gone through the difference between differentiation and integration there in part B, part 1. So integration is just the opposite. It's undoing the differentiation. And again, we had to include our plus c here. But we were given that extra piece of information, f of 2 is equal to 0, to find out what our c was. And the second part we went through there was, first of all, finding the points of intersection. So that's where we let our two functions equal to each other. And for the area, it's always the top function minus the one on the bottom. Okay, so just to go right back up here again, as I said, those are probably your 4 main parts of integration. Now, I haven't gone through the average value, so I didn't get to go through this with you. But in that question, as I said, that question in the chat on the length of a day in Galway, so 2015 paper 1 question 9, the last part of that question works through that average value formula. And it's pretty self-explanatory. You basically just sub in your b and your a and your f of x there. Okay, so as I mentioned last week as well, the calculus, so differentiation and integration are huge parts of paper 1 every single year. So it's important that we take the time to go through them and really understand exactly what we're doing. Okay, so looking forward to chatting to you all next week. Thank you.